Dear students, now I am taking a problems on single degree of freedom system. The first problem is determining the natural frequency of compound pendulum. In this figure, we can see here O and G. There are 2 points where the mass M is connected. Okay, in this the O and G is makes an angle theta. Means what here? The pendulum is in displaced position from rest position. Let first M is the rigid body, mass of rigid body. L is the distance of point of suspension. See, this is L, distance of point of suspension. Next, O is point of suspension. This is the point of suspension. And G is center of gravity. G is center of gravity. I is moment of inertia of body. That can be calculated by this formula. I is equal to m k square plus m L square, that is m is equal to k square plus L square, where k is the radius of gyration of body, where OG is displaced at an angle of theta. Okay, see, OG is displaced at an angle of theta, where restoring torque can be taken as minus mg sin theta. We will take a negative direction, minus mg sin theta into this distance L. This is what we are taken here. As the angle is very small, what we did, the sin theta is equal to approximately is equal to theta, and the answer we have taken here mgl sin theta. Okay, according to Newton's second law, acceleration torque is equal to restoring torque, that is I theta double dot is equal to minus mgl theta, that is theta double dot is equal plus mgl divided by I into theta, where in the place of I we have taken m into k square plus L square. Okay, so we have replaced I by that value. Now we got theta double dot plus gl divided by k square plus L square into theta is equal to 0. Now to calculate natural frequency, we need a value of omega n. So we went to first for calculating omega n. That value is here. Omega n is equal to root of gl divided by k square plus L square radian per second. Hence natural frequency may be, it will come Fn is equal to 1 by 2 pi into omega n. We know the value of omega n. Put the value of omega into that will be 1 by 2 pi root of gl divided by k square plus L square hertz. This is what the first problem of the same. Now I will take another problem, that is a block of mass 0.05 kg is suspended from a spring having a stiffness of 25 Newton per meter. The block is displaced downward from its equilibrium position through a distance of 2 cm and released with a upward velocity of 3 cm per second. So they told to calculate natural frequency, period of oscillation, maximum velocity, maximum acceleration and phase angle. So first we'll take a diagram of this spring and a mass system, where the given value is mass is 0.05 kg, the stiffness they have given 25 Newton per meter, the displacement is already given x naught 2 centimeter, and the velocity is given, that is 3 centimeter per second. We know that differential equation x double dot plus k by m into x is equal to 0. So x of t is equal to a cos omega n t plus b sin omega n t, where we know that x is equal x into cos of omega n t minus pi. When the t is 0, x of 0 is equal to x0 is equal to a is equal to 2 centimeter. Now we will differentiate the thing to get the value of v naught. Okay, already the v naught value is given. We need to calculate the value of b. So what? X double dot is equal to v naught is equal to b into omega n. Okay, that's why b is equal to v naught by omega n. To calculate the v naught, we know that omega n is equal to root k by m. So root k value is already given, that is 25 Newton meter and 0.05 kg. That answer comes, that is 22.36 radian per second. Now need to calculate maximum amplitude, that is x value. That's what? That is a square plus b square. Okay, this can be taken as root of x naught square plus v naught square plus b omega n square. After putting a value, they are given the x naught in displacement, they are given 2 centimeter. I have taken here, and next they are given velocity 3 centimeter per second. I have taken 3 centimeter per second and calculated the value omega n 22.36. so total x amplitude is 2.0045 centimeter. Now first we'll go for calculating natural frequency, that is fn is equal to omega n divided 2 pi into omega n. So 1 divided by 2 pi into place the omega n value, that is 22.36 radian per second. That answer came is 3.56 hertz. Okay, next the asked period of oscillations means time period, t is equal to 1 divided by fn. So we know the value of fn here 3.56 hertz. So 1 divided by 3.56, that is 0.28 second. Next we will calculate maximum velocity, that is x dot maximum, that is x omega n. X is, we know, 2.0045 centimeter from here, and next omega n is 22.36. the answer came 44.82 centimeter per second. Now we will go for maximum acceleration. From maximum acceleration, x double dot max, that is x omega n square. Again x means again what here, x dot max into omega n, means we will take a value of first this, we will multiply by omega n value, that is 44.82 into 22.36, this value. Okay, the answer comes is 1002.2 centimeter. Okay, next centimeter per second it came, and lastly we need to calculate, that is a phase angle. That phase angle can be calculated by pi is equal to tan inverse of v naught divided by omega n into x naught. This is a equation. So tan inverse of 3, we know the velocity x double dot is 3, here it is given value, and next omega n calculated 22.36 into 2, again this is a given value 2. Okay, from this we calculate a phase angle of 3.838 degree. Okay, this is what two problems of single degree of freedom system. Next problem will take soon. Thank you.